When to use standard form and when to use slope-intercept form. First of all, standard form is ax plus by equals c, where a and b are coefficients on the variables x and y. Then we have our equal sign, and c is the constant. In this form, it is quite easy to find the x-intercept and the y-intercept. In slope-intercept form, it is written y equals mx plus b. Variable y is isolated by itself with a silent coefficient of 1. After the equal sign, we write the x term. The coefficient in front of x is the slope, and slope is identified with the letter m, and it's usually written as a fraction with rise over run. The constant b at the very end is the y-intercept, and it's typically just written as b equals, but we could also write it as an ordered pair, 0, whatever your b value is. I have 3 examples that are not written in any of these forms, and I will select one of those forms and then graph it. So number 1, y plus 5 equals 2x. I would choose to change this equation into slope-intercept form. The reason is that y has a silent coefficient of 1, and the 5 can be moved over to the right with subtraction. Y equals 2x minus 5. I can see that the slope is 2, and I can see that the y-intercept is negative 5. When I graph in slope-intercept form, I start down or up on the y-axis with the value that my y-intercept is. My y-intercept was negative 5, so I'm starting down at negative 5. Then I take my slope, and I remind myself that that slope is a positive 2. As a fraction, that's 2 over 1, which means I need to rise 1 and rise 2 and run 1. And I do that starting from the y-intercept. I go up 2 and over 1, up 2 and over 1. And I can do that as many times as I need to be able to draw a straight line. The second problem, 3y minus 6x equals 12, is really close to standard form. The x term and y term need to move locations. They're not actually switching to a different side of the equal sign, so this symbol will stay the same on each variable, negative 6x and a positive 3y. Now the x-intercept is the ordered pair where we have an x value that we need to find still and a y value of 0. If I were to put 0 in for a y value, I know that this term of 3y would just become 0. So I'm left with the statement negative 6x equals 12. If I have negative 6x equals 12, and I solve it for x, I would divide by negative 6 and get negative 2. So my x-intercept is negative 2. On the x-axis, I'll be crossing at negative 2. For the y-intercept, I know the ordered pair has an x value of 0. So in my equation, if I were to put 0 in for x, the x term would disappear, and I would have 3y equals 12. So dividing by 3, I have y equals 4. My y-intercept is on the y-axis at positive 4. I have 2 points, and I draw a straight line through those 2 points. Problem 3, 9y minus 3x plus 5 equals 0. Now this one could go into either form, and I actually am going to change this to standard form for the reason that if I were to change it into slope-intercept form, I would be subtracting the 5, and then I'd be dividing by 9. I'd be doing other things, but 5 divided by 9 would be my y-intercept, and that's a fraction. Having a y-intercept as a fraction is a bit of a challenge when I am using slope-intercept form. So I'll change this to standard form. I'll have negative 3x still on the left-hand side, positive 9y equals negative 5. My x-intercept will have a y value of 0. So if I put 0 into the equation for the variable y, I have the statement negative 3x equals negative 5. Dividing by negative 3, I have x equals 5/3. On a graph that's difficult to sometimes visualize, remember that's a mixed number 1 and 2/3. On the x-axis, I am at 1 and 2/3. My y-intercept has an x value of 0. I substitute 0 in for the variable x and have the statement 9y equals negative 5. So the y-intercept is negative 5/9. And I do my best to locate that, on the y-axis at negative 5/9.